Hello everyone, I am Carole A, lecturer at the Faculty of Engineering, Alexandria University, Architecture and Engineering Department. Today I'm presenting my research on BIM in healthcare systems, a strategic roadmap for adoption in Egyptian healthcare facilities. In part 1, I'll talk about the problem statement, objectives and methodology. Then I will explore the local case studies being analyzed. In part 3, I'll discuss the survey results. And in part 4, I'll present the suggested roadmap. And I'll finish with the conclusion. We'll begin with the introduction. We all know that healthcare facilities are critical infrastructure. Recent global events, particularly the COVID-19 pandemic, acted as a powerful catalyst, highlighting the urgent need to expand our healthcare systems efficiently. This accelerated the adoption of digital technologies globally. However, while the world is moving toward digital twins, in Egypt we still face a significant gap between the theoretical capabilities of BIM and its practical implementation on the ground. Let's look at the context. Globally, countries like the UK have government mandates driving BIM adoption. In Egypt, however, the situation is different. Our adoption is currently middle out, meaning it is driven by large private contractors and consultants, rather than by government policy. The lack of localized strategic framework and unrealized life cycle potential are the main problems addressing the BIM adoption in Egyptian healthcare system. The research aim is to improve the performance of Egyptian construction industry, especially healthcare facilities. The research objectives are to investigate the global and local practices, to examine the local context, and to develop a strategic roadmap for BIM adoption in Egyptian healthcare system. To address this, I employed a mixed methodology approach. First, I conducted a systematic literature review focusing on global strategies. Second, I analyzed local case studies of 3 major Egyptian hospitals to see what is happening on the ground. Then, I validated these findings through an expert survey and interviews with Egyptian AEC professionals to understand the local market barriers. And finally, this triangulation of data allowed me to build a roadmap that isn't just theoretical but rooted in Egyptian market reality. My research analyzed 3 landmark projects and the results were telling. First, the Madinti Medical Center. This project proved that Egyptian firms can achieve LOD 400, that is, fabrication level detail. They used BIM to generate shop drawings for complex MEP systems, achieving zero clash installation. Second, the 500 Cancer Center. This project is pioneering the move toward level 2 maturity, aiming for a full digital handover that supports future facility management. Third, the National Eye Hospital. The most striking finding here was the financial impact. By resolving clashes in the model before construction, the project reported budget savings of approximately 30 to 35%. Despite this success, our survey revealed significant barriers. Data collection was conducted using a purposive sampling strategy targeting subject matter experts within the Egyptian AEC industry. The respondent demographic was composed of architects and structural engineers. The sample represented a diverse range of expertise. The majority fell into the mid to senior level categories. Regarding BIM knowledge, respondents reported knowledge levels ranging from good to very good. However, a significant gap in specific healthcare application was identified. 60% of respondents indicated that their companies had not yet implemented BIM in healthcare projects, while 40% reporting utilizing BIM across both the design and construction phases. When we asked professionals about the benefits of BIM adoption in healthcare facilities, they indicated that BIM process helps improve the coordination of MEP systems in hospitals, reduce the rework and material waste in construction phase, and improve operation and maintenance efficiency in hospital after handover. When asked about the biggest barriers, the lack of skilled BIM professionals and training, and the high cost of software and implementation, as well as the lack of government regulations and mandates, topped the list, followed by resistance to change, interoperability, and lack of client demand. In addition, the survey showed that the most effective drivers are education and universities in the first place. Then the government must take charge. Without government regulation and incentives, adoption will remain fragmented. And finally, the market. Large private developers and private sector must lead to BIM adoption. The survey results indicate that we have a diffusion gap. We struggle to collaborate effectively and lack standards to integrate data across project lifecycle. Now, for the strategic roadmap, based on the diffusion areas model, I propose 3 pillars. The first pillar is the policy, the driver. We need the government to shift from observer to driver. This includes expediting building permits for BIM compliant projects and offering tax incentives for BIM ready contractors. Pillar B, the process, the methodology. We must adopt prototyping. Instead of designing every hospital room from scratch, we should develop a library of BIM prototypes for standard units like exam rooms. This ensures compliance with healthcare codes and speeds up delivery. For the third pillar, the technology, the enabler, we need to standardize LOD 400 for fabrication and mandate a common data environment to solve the information transfer problems. 3-phase timeline was proposed for implementation. Phase 1, years 1 and 2, the foundation. We start with awareness and pilot projects in the public sector, similar to the UK's early strategy. Phase 2, years 3 to 5, the standardization. Here we enforce mandates for all public healthcare projects, exceeding a certain budget and standardize our prototype libraries. Finally, phase 3, years 5 plus, the integration. We link the baseline model to hospital information systems, achieving a true digital twin for operations and maintenance. To conclude, BIM is enhancing healthcare design, but technology alone is not enough. Studying the local context, a shortage of talented BIM coordinators was noted, and there is a lack of awareness of the importance of applying this methodology in the Egyptian healthcare sector. The research recommendations are: 1. Policymakers must create the market through legal frameworks. Making BIM mandatory or obligatory for project authorization, building permits, and licensing is a critical action. Creating a mandatory national BIM standard and implementing guidelines is necessary, and launching a unified national BIM platform for standards, templates, and an object library is proposed as a key action. The second point, universities must bridge the skills gap by teaching practical fabrication-ready BIM, not theoretical modeling. This can be achieved by integrating BIM into universities and academic curricula, and establishing training centers for engineers. And finally, the private sector must mentor the supply chain to lift the entire industry standard. Thank you so much for your time.